Hello, I'm Dr. Zyata here. This video tutorial is solution to problem 4.34 from Engineering Mechanics Statics 9th edition by G.L. Meriam, L.G. Craig, and G.N. Bolton. Statement of the problem is calculate the forces in member B, C, B, E, and E, F. As member forces in B, C, B, E, and E, F required, so only three members. So I'm going to solve this problem using method of section. So steps to find member forces using method of section is need to plan a cut that passes through the target member. Target member are B, C, B, E, and E, F. And on the cut, there must be three or less unknown forces. And the cut is going to split whole truss into two stable parts. The next one is need to choose simpler side of the cut. So there are two sides here. One the right side. Right side contain only one load and the left side contain three reactions. And those three reactions are unknown. So as it's possible to solve this right section without finding reactions, so support reactions are not needed there. So then after choosing the simpler side, need to draw free body diagram, and all external loads or reaction on the side must uh, be presented. And unknown cut member forces, I'm going to assume them as a tension, so arrows away from the cut. So now I'm going to draw its free body diagram, and then I'm going to explain how to solve this problem. The free body diagram of right section or right part of the truss is being drawn here. So 14 kilonewton is shown here as one known, and B, C, B, E, and E, F, they are shown as three unknown member forces. So there is a condition in the question. It says solve each of force from an equilibrium equation. Equilibrium equation means that sigma fx equal to 0, sigma fy equal to 0, or sigma m equal to 0, which contain that force as only unknown. So need to use only one equation for each unknown. So there are three equations there, sigma m equal to 0, sigma fx, and sigma fy equal to 0. So for sigma m, choose a moment point that has the most unknown to eliminate as many as possible and need to resolve in grind member into the components. So the only possibility here when we are going to get one moment equation is need to take the moment about a point, so to eliminate other two forces. So now if I take moment about point C, so if I take moment about point C, so then it is going to eliminate BC only. So I need two equation to find these two unknown. And if I take moment about point E, so then BE and EF, they are being eliminated. And then the only unknown left is BC. So I can use sigma m about point E equal to 0 to get an equation which contain only one unknown BC, and only one equation can be used to solve BC. So I'm going to take moment about point E. So take moment about point E, there are about point E, so there are two forces, one unknown BC and the other one is 14. So the line of action of 14 is going to act somewhere there, and the perpendicular distance is, that is 3 meter is the perpendicular distance, and then that 14 is going to produce moment in, that is in clockwise direction. The other one is BC. So BC is acting along that CD line, and the perpendicular distance from the line of action of 4 to the point of rotation E is 2 meter, and then BC is going to produce moment in CE in anti-clockwise direction. So taking clockwise negative, anti-clockwise moment as positive, so I can get that minus 14 times 3. So that is minus due to clockwise plus BC times 2, and then solving it, so BC comes as plus 21. So now the next one, in the interpretation of the sign of unknown member forces, a positive value indicate tension and a negative value indicate compression. Because the answer is positive, so BC is 21 kilonewton in tension. So that is one unknown is being calculated using one equation of equilibrium. Now the next I need to select any point so that I can eliminate two of the forces, because BC is now calculated and I need to select a point. So now if I take moment about point B, so then BC and BE are going to pass through it, and then only equation left, that will be EF. Oh, sorry, only unknown left is EF. So by taking moment about point B, it is possible to eliminate BC and BE and write an equation which has only one unknown EF. So I'm going to redraw the free body diagram. So that is the same free body diagram, but point B is being included here. So if I take moment about point B, so BC and BE are going to eliminate. Then I have EF. Now EF is an inclined member, so I need to resolve it into its component. And to resolve EF into its component, so I need to redraw here some right angle so I can find out components of EF. So now I have drawn a perpendicular from point E to BF at point E dash. So by drawing a perpendicular, so then BE dash will become equal to CE. So BE is 2 meter, and then total BF is 3 meter. So then E dash F will be 1 meter. So now I'm going to use triangle FE dash E to find component of EF. So that is uh, a triangle for EF with vertical side as 1, horizontal side as 3, and its hypotenuse are diagonal as root 10. So now EF is being resolved into two components, EFY and EFX, and then I'll find EFX and EFY using that triangle rule. So if a force F is given and need to find its component, and F is being represented as a right triangle with horizontal distance as x, vertical distance as y, and then hypotenuse and z. So fx is equal to f times x over z, fy is equal to f times y over z. So now I'm going to write moment equation about point B. And for moment equation about point B, the first one is 14. So that is a line of action of 14, and the perpendicular distance from line of action of 14 to B is BCD, which is equal to 6 meter. And it is 14 is going to produce moment in clockwise direction. The next one, the line of action of EFY is along CE, and its perpendicular distance is BC. So now then EY is going to produce a moment in clockwise direction. Then for EFX, so the line of action of EFX is somewhere there, and then its perpendicular distance is equal to CE 2 meters. So that is a perpendicular distance, and it's again going to produce a moment in clockwise direction. So all three moments, 14 times by 6, then EFY times by 3 and EFX times by 2 are in clockwise direction. So all are taken as negative. So now the moments are minus 16 times minus 14 times 6 minus EFY times 3 minus EFX times 2, and then it can be written as 2EFX plus 3EFY minus 84. EFX is EF times by horizontal side over hypotenuse, and then EFY is vertical side over hypotenuse using these two relations is equal to minus 84. And then by simplifying, EF comes as minus 84 root 10 over 9, and that is minus 29.5146. And then again interpretation says that a negative value indicate compression, because EF is negative, so it is going to it is compression. So EF is 29.5146 kilonewton in compression. So now the last unknown left is BE. So BE, and again we need to find a point so that we can eliminate BC and EF, and we'll get only BE. And it is possible if we extend the line of action of BC towards away from D and line of action of EF away from E. So then we'll see that where both of these two lines of action are going to pass. So if we take moment about that point, then it is possible to find a single equation which contain BE. Now if I extend CD beyond D, And then if I extend that Fe beyond E, so they are going to meet at a point which is, I'm going to say that D prime or D dash. So now using the similar triangle rule, so if I'm going to use similar triangle rule, so D to D dash distance comes as 3 meter. So, and then if I take moment about point D, so B, C, and E, F both are going to pass through them, or their line of action actually going to pass through them. So then uh, by taking a moment about point D dash or D prime, you're going to eliminate B, C, and E, F. And then I need to find, because BE is inclined component, so I need to find its component, and for that component I'm going to use triangle BEE dash, and that BEE dash vertical side is 2 and horizontal side is 3. So then I am going to uh, resolve BE into their component, and then going to take moment about point D prime. So now I have resolved BE into its component BEX going towards negative y-axis, x-axis, and BEY towards positive y-axis, and then I'm going to take moment of 14 about that point D, and then moment about of 14 about point D is going to be, that is anti-clockwise 14 times 3, and then the line of action of BE is going to pass through somewhere here. So let's say that is BE, and its perpendicular distance is equal to CE, which is 2 meter, and is going to produce moment in clockwise direction. And then left is BEY, so that is a line of action of BEY, which is CE, and the perpendicular distance is CD dash. So BEY is going to produce moment. So that is the direction of the moment it is going to produce clockwise. Okay, so now I have find out all the direction and the magnitudes of the moment. So I can write now equation for moment about point D. So sigma m d equal to 0. So that is 14 times 3 positive. BEY times 6. So that is clockwise direction minus BEY. So that is a clockwise direction. And then BEX times by 2. That is again clockwise direction. So then the equation can be written as 2 BEX plus 6 BEY equal to 42. Now BEX is calculated as using rule there. So BE comes as horizontal side divided by the diagonal, BEY, that is a vertical side divided by the diagonal, and then simplifying it. So BE comes as 42 root 8, 13 over 8, and it is positive 8.413. And then a positive value indicate tension. So then BE is positive. So that is tension. So BE is 8.413 kilonewton in tension. The answers at the back of the book are BC equal to 21 kilonewton. So BC is 21 kilonewton in tension. BE comes as 8.14 kilonewton in tension. So BE is 8.41 kilonewton in tension. And then EF is 29.5 kilonewton in compression. So EF is 29.5 kilonewton in compression. So that is a complete solution to this problem. Thank you very much for watching.